Hey gang, we're going to look at an introduction to significance testing. This is definitely something that you would see more in an AP Stats class, so we're just going to touch on it. We're not going to go into all the details, but we want to expose you to some of the ideas behind significance testing. So, we're going to start off by talking about something called a null and alternative hypothesis. Okay, so the statement being tested in a significance test is called the null hypothesis. And we use this notation here. We call this H0 or H0. And that tells us that it's the null hypothesis. And so, for example, we might have a null hypothesis that says that mu equals 115. Maybe we're looking at IQ scores. And we believe that we're told that the average IQ score of Wisconsin students is 115. Okay, so that's what we'd be saying here. Somebody told us, or we found some information somewhere that says that the mean IQ score of Wisconsin students is 115. Okay. Well, the significance test is designed to assess the strength of the evidence against the null hypothesis. So we're going to collect a sample, and we're going to look at that sample and say, all right, how strong is this evidence against the null hypothesis? Does it prove this null hypothesis wrong, basically? Usually the null hypothesis is a statement of no effect or no difference from historical values. So, it's the 115 is maybe what we read about the IQ score being 10 years ago. And so we're assuming that it's not any different than it was before. Okay? A lot of times mu might equal 0 because you're assuming no change in things. Okay? But then we've got the claim about the population that we are trying to find evidence for is the alternative hypothesis. So now we're going to say maybe we believe that students at our school have an IQ that's higher than the state average. So our alternative hypothesis, which we denote HA, we would say that mu is greater than 115. So our null hypothesis was that the mean IQ score is equal to 115. Our alternative hypothesis, because we believe we've got stronger students at our high school, is mu is greater than 115. So we believe it's higher than 115. Okay. One thing you want to do is you want to always make sure you state the null and the alternative hypothesis in terms of a population parameter. So what that means is, if we're talking about means, we're using mu. Okay? So we're going to keep it nice and simple there. Also, it is not good practice to first look at the data and then come up with your alternative hypothesis. So you don't want to look at the data, you don't want to take those IQ scores, find a whole bunch of IQ scores from students at our school, and then come up with your alternative hypothesis. What you'd like to do is, you've got some idea, you believe that our IQ scores are higher, so you write your alternative hypothesis, and then you go out and find the data, and you look at the data and see if it supports that. Okay. Don't worry about the conditions here. That's something we'll deal with later. The test statistic. We're going to be actually using Desmos to calculate this, but the test statistic, we would take our estimate, so we would take our sample mean, whatever we get when we average the people in our sample, and we would subtract that null hypothesis. Okay, so let's say in our sample mean, or in our sample, we get a mean of 120 for our IQ. We would take 120 and we would subtract 115 because that was our hypothesis. And then we would divide by the standard deviation. And this is where it gets a little bit trickier with what we're doing now. Again, we're going to be doing this on Desmos, but we would take the standard deviation of our sample that we collected and divide it by the square root of how many were in our sample. So if we collected 30 people for our sample, we would take our standard deviation and divide it by the square root of 30. And that's what would go on in the denominator of this fraction. Okay? And that would calculate your test statistic. But again, we're going to have Desmos do that for us. And then we get a p-value. So Desmos, again, is going to do this for us. But if you take a class like AP Statistics, you're going to be doing this on your own. Okay? The p-value is the probability that assuming the null hypothesis is true. So we always assume that the null hypothesis is true. The p-value is the probability that what we observe would happen, something that we observe or more extreme. So for example, we would assume that the IQ score of our students is 115. That was our null hypothesis. The p-value would be the probability that we get a sample of, let's say, 120 or higher if we assume that the null is true. Okay? So it is possible that the average IQ score at our school might be 115 and we collect a sample and we get 120. That's possible. But it could also mean that our IQ scores are actually higher than 115, and that p-value helps us determine the probability of that. Okay? The smaller the p-value is, the less likely we would get those results if we believe that the null is true, which means the smaller the p-value is, the stronger the evidence against the null hypothesis. Okay? Typically, just look at this last portion here, alpha equals 0.05. So typically, we look for a p-value that's less than 0.05. Now, that doesn't mean that you're always going to use that. That's just kind of the general standard. Because what you're saying is, if it's 0.05, that would be like 1 in 20 times that we would see these results. So if our p-value is less than that, we're saying it's pretty unlikely that we would see these results just happen by chance. And what that means is, it's probably more likely that our null hypothesis isn't true, and that we found some evidence to support our alternative hypothesis. Okay? We call that basically statistically significant evidence. Significant in this case does not mean important. Okay? It just means not likely to happen by chance. So we're saying if it's 0.05 or less, there's less than a 1 in 20 chance that this would happen by chance, which means we might believe that it's more likely our alternative, we've got some evidence for our alternative hypothesis. Okay? So that's kind of a little introduction to statistical significance, p-values. We're going to look a little bit more at this with some actual examples so that you can see this in practice. Okay? So look to the next video for some examples where hopefully we'll kind of solidify this material. Thanks.